Hey, welcome to Func Prog Sweden at Kivra. Third Func Prog Sweden this year. Yeah. Cool. So I'll go over to the agenda immediately. First, we'll do a short introduction by me, Magnus Sedlacek. I think I've said hello to most of you, otherwise I'm Magnus. I'm the guy organizing this meetup. I'm rarely speaking, I'm just do a short introduction every day, and then I'll hand over to the presenter. And the presenter of today is Josh. He will do REPL-driven driving the browser. That's the topic. We'll see what it is. Also, again, thank you very much, Kivra, for sponsoring with venue. It's a very nice venue. And also, I think everyone enjoyed the food, the chips. So if you're not here, make sure to come to Stockholm and Kivra next time we're here. Thank you very much, Kivra. Also, thank you very much, Other Beat, for sponsoring the video stream. And if you want to know more about Other Beat, just head over to internet and check them out. The coming schedule then, next meetup will be in 9th of April. And then we'll do another meetup in May and another meetup in June. And hopefully we'll find some people that wants to present here in Stockholm, because then we'll do it at Kivra or some other place again, here. And of course, you want to support the Func Prog Sweden community, so you head over to MeetUp and you join the community. And you make sure to subscribe to our channel and write good comments, nice comments, hopefully, on YouTube. You can also jump into Discord, because sometimes it's tricky to ask questions on YouTube, because they don't allow enough characters to be said in the chat. So then it's easier to ask longer questions or more elaborated questions on Discord. And questions. So if you have questions live here, please use the mic. And if you have questions on internet, live stream, shoot out the questions in the chat, and I will read it up to Josh. With that, let's start. Warm welcome, Josh, to Func Prog Sweden. Warm welcome.
Thank you. Thank you. And thank you at home. I'm told that that's the place to look. You should put a cowboy hat on top of that camera.
Oh, yeah, we will do.
But, yep.
Thank you. I'll give it over to you.
Thank you very much.
Yes.
All right. So now let's actually switch tabs here, right? So now we have maybe. Yes. Now we have an amazing REPL being driven at high speeds. Don't try this at home. So I am Josh, and usually I have an intro slide in my talk where I brag about how awesome I am and how much I know about everything. I didn't put one in this time because I realized that actually I don't know everything, and whether I'm awesome or not is in the eye of the beholder. So here you have a white screen, and you'll have to judge for yourself from what I'm talking about, whether I in fact know what I'm talking about. So I have to admit to you, I have a problem. And actually, I have quite a few problems, but for the sake of brevity, let's just focus on a subset of them tonight. So specifically, the problem I want to talk about is that I want to do functional programming. And sometimes I need to do that functional programming in a web browser. And there is a language called JavaScript, and functional programming can be done in it, and it looks like this. I'm not here to throw shade on JavaScript, which is a lovely language which many people have done many amazing things in. What I am here to say is that, to me, this is not aesthetically pleasing. And also, JavaScript mutates values, which is a weird concept to me. So luckily, there is a solution to this problem. It is called ClojureScript. So ClojureScript is one of those magical transpiled languages. So there is a thing called the ClojureScript compiler, which is written in Clojure, of course. So that's running on the JVM, and it takes ClojureScript, which is more or less the same language as Clojure, mostly more, but a little less. And we might talk about that a little in this talk, but probably not. So I don't know why I brought it up. But anyway, so ultimately, ClojureScript ends up as JavaScript minified, squashed into your browser. So far, so good. And this is what ClojureScript looks like. So, I mean, this is not ClojureScript, sorry. This is what it looks like to engage with ClojureScript. So I am running a Clojure command here to invoke the ClojureScript compiler to actually compile a thingy, this hello world.core namespace, and I'm saying also give me a REPL. So this is super awesome. When I do this, I get something that I can't click on. Anyway, no worries. What I get is an amazing browser window here. And then over there, I get an amazing REPL. And I don't know if you can actually see this because it's very, very small, but I am evaluating an expression in the REPL. So I'm saying, Clojure, tell me about the number 1. And it replies back, the number 1 is in fact the number 1. This is a REPL, very powerful technology. However, as a normal human being, I want to be in my text editor writing code. And since I am not a human being that hates myself, I like to be in Emacs writing code. I, of course, want, I heard, okay. I'm sure people at home are like throwing stuff at your screen. It's fine, whatever. You know where I live, kinda. So I'm in Emacs. I want Emacs to like go ahead and connect to my REPL so I can do awesome stuff. And with this particular ClojureScript setup, that is not happening here, or at least I have never been able to make that happen. So I don't want to be sitting over in a terminal somewhere, like communicating with my running process. I want to be in my editor doing that. Okay, cool. So that's a problem. This is no bueno. Okay, how do you say that in Spanish? No bueno in Spanish? Is it this? Oh, it's the same. Okay, one of those loan words. Okay, so now I'm back faced with another problem. Of course, there is a solution to this problem. It is something called, oh, right. Sorry, I skipped a problem. But anyway, you see what I'm doing here. Problem, solution, problem, solution. So yeah, this top thing here, I was supposed to talk about Figwheel and how it is the solution to the problem of getting a REPL running in your browser and attaching to it from Emacs. I failed to mention that. The reason I think it's a problem is because it's a little bit complicated. There are a lot of moving parts, and I don't know how to use it very well. So anything I don't know how to use very well, I'm just going to say is a problem. And obviously, the problem is usually between the keyboard and the chair wall, as they say. So I will just admit that this is probably only my problem, but there is a solution, and it is Shadow CLJS. So I don't know if you can read this, but Shadow CLJS says that it bridges the last stage of the ClojureScript compiler build process with better tooling and experience. And it does, in fact, do this. That it does what it says on the 10. It's very wonderful. And I can highly recommend it unless you're me. Because the wonderful thing about Shadow CLJS is it has, it's really well kind of integrated with the JavaScript ecosystem, which includes things like NPM and Yarn and all that stuff that I don't understand. So the person who created Shadow CLJS, a really lovely guy named Thomas Heller, very supportive, made a very good design decision, in my opinion, to not build all sorts of abstractions over top of the JavaScript ecosystem, but rather build tooling that works well with it. The problem is when you're a person like me who has no idea what NPM even is, and sometimes you type NPX and I don't know what's happening here, and then Yarn is like NPM++ or something, I get confused, and the fact that there are no abstractions mean that like my lack of understanding is actually a problem. There's a solution to this. And that's what I'm going to talk about today. I'm going to talk about a wonderful way of life, which is called Babashka plus Skittle. And I probably should start explaining what these things are. So unless you're in the Clojure community, maybe you have never heard of either of these things. If you're in the Clojure community, you may not have heard of Skittle, but if that is the case for you, you're in the right place. So what is Skittle? Going to the Skittle webpage, and by webpage, I mean GitHub repo, it says it is the small Clojure interpreter exposed for usage in script tags, right? Very self-explanatory. I could have just end the talk here. I've told you what Skittle is. Okay, so this small Clojure interpreter thing, what in the world is that? So this often is called Sci or Sci, SCI, Sci. I call it Sci, I don't know. The person who wrote Sci is actually either watching this live or will be watching it later, Bork Dude, so I don't know how you pronounce it. I say Sci. You can be mad at me online, it's cool. So Sci is a configurable Clojure and ClojureScript interpreter suitable for scripting and Clojure DSLs. Okay, what does all that mean? So it is a Clojure interpreter written in Clojure, right? So I'm sure everyone in this room has, of course, read Structure and Interpretation of Computer Programs. So you will know this is a metacircular interpreter. And I actually had to look that up to make sure I told you what it was in words that would make you superior nerds out there not laugh at me and say, well, actually, I'm sure I'll still mess it up, but a metacircular interpreter. See, now you get to laugh at me. A metacircular interpreter is an interpreter written in itself. So typically what you do is you have a host language, you write a tiny little core, and then the rest of the interpreter you implement on top of that tiny little core. So that's a metacircular interpreter. Well, actually, says someone on Discord. So it is a bunch of Clojure code that lets you do stuff like this. Amazing, right? I can't believe there wasn't applause for this. This is like, thank you. Wow. Okay. Thanks. I can't believe I have to beg for it either. Come on, people. All right, so this is, Sci is the small Clojure interpreter. It has a function called eval string. If you feed it some Clojure code, it evaluates that Clojure code. Amazing, right? That's why it's an interpreter. And it is also, I claim, and I mean this from the bottom of my heart, it is the key to unlocking the door to Clojure for everything, everywhere, all at once. Like my visuals? It's the GIMP. It's the GIMP. All right. So I have said a lot of stuff, but the first rule of writing and apparently presenting meetup talks is show, don't tell. So I have put this little icon on my slides to remind me when it's time to take a deep breath and go over to Emacs and promise some amazing stuff is going to happen. How big does it have to be to actually read it in the room? Oh, God. Okay. Let's see what we can do here. I was hoping for larger text on the screen. Okay. So what I'm going to do is demonstrate what it means to wrap the small Clojure interpreter in just enough JavaScript to let you do stuff with it in the browser. So let's make a web page, shall we? So I will, and I know you can't read my menu buffer, it's fine. I'm just going to create an index.html page here. And I'm going to embiggen as much as humanly possible. I think this is the best I can do for folks in the room. Is this acceptable? Okay, thank you very much. Or thank you for not complaining if it isn't. So you didn't see this, but like I did not, like a chef, pre-bake this. I just opened a file called index.html and Emacs was like, you must want an index HTML file. Here's one for you. So that's awesome. Sorry. Oh, I can't really see. Okay, yeah. So let's give this page a title, and let's say that it is a boring page, because right now it is super boring. And if we pop down here in the body, let's write ourselves some, like a div maybe, and then let's call it like text. And then like in here, we can say this is boring. And then we can maybe like have an emoji because this is like 2014. No, off by 1 decade. This is 2024. Welcome, Josh, to the future. All right, so we have a div here. This is a super boring page. And to demonstrate just how boring, I'm going to open a tab over here. Let's close down that. Let's make this like full screen or whatever. Let's open in, nope, this is my live demo. So it's in live, and then there's public, then there's index.html, and then this page is super boring. So I've demonstrated to you how Emacs can write a web page for me, and I have to write a few lines. So far, so good, right? This, oh, wow, I didn't even have, wow, amazing. So the Pavlovian response is, when I reach for my water bottle, you applaud. Okay, thank you. We'll keep practicing this. All right, so this is the type of amazing live demo that y'all signed up for, one that works perfectly with no errors, he says. All right, so this is HTML. Let's start talking then about Skittle. So up here in the head section, let's just sprinkle some Skittles in our HTML. And I have actually prepared, because I never remember the link to this, a file called cheating, which has some tags in it, which I'm now going to paste over in here. And I could have done that without just enlarging the font, and you never would have known I did it, right? So I shouldn't have even, shoot. Okay. Let's then reformat slightly here. It's going to be super hard to see, but so what I have here is a script tag of type application JavaScript, right? There. And I am downloading some file from, oh my goodness, NPM is involved. You never would have guessed that, would you? There it is. And then down here, I have a script with a strange type of application X Skittle. Okay. What I can do inside my Skittle tag is I can actually write some ClojureScript code. For reals. I'm not even making this up. So some awesome ClojureScript code would be like, hello, Skittle, for example. That is valid ClojureScript. All right, so let's see what happens when I go back in my web page and I remember how to use my window manager. Perfect. I reload the page, everything is fine, everything is boring. Let's open the inspector. And if I click down here and embiggen, too much, sorry. I don't know if you can see this, but it says hello Skittle. So I have just executed ClojureScript in my browser, and that was amazing. So if I go back over here, maybe we'll make the ClojureScript a little more exciting than just like a hello type thing. So let's make this boring web page maybe a little more exciting. So I'm going to write a little function called maybe excite me, bang. We'll put an exclamation mark on it to make it extra exciting. This function is going to take no arguments, and then it's going to do stuff and things. Let's maybe make that stuff like println. Oh no, you know what's even better? What's better than println is alert. Yeah. JavaScript alert. OMG. All right. Now we have an amazing function written. And of course, on this amazing function, let's see, what do we do with the function? I think maybe we need a button now, probably. You know, buttons are cool. So we have a button, and then we say on click, and we say excite me. And like my Clojure function is called excite me. And in Clojure, of course, this is how I would call a function, obviously. However, JavaScript is not as much fun as Clojure. So it doesn't let you have dashes and symbol names. It doesn't let you get excited when naming your stuff. So I have to do this boring thing, and then I have to put the parens here. I don't understand what's happening. Anyway, so I have a button, I have an on click, and I am going to say in my button, excite me, and then 3 exclamation marks, why not? All right, so now I have a page and I have a button. Let's just, you know, go over here and I have a button, wonderful. Okay, I click it, doesn't do anything. It just tells me that there's no such function down here. This is gonna be fun when we have to make mistakes and read about them in the paper. So let's do something a little more awesome. So what we need to do then is export from ClojureScript a function that JavaScript knows about. So the way we can do this is, remember when I made a snide remark about mutating values earlier, and now I'm just breaking out a set function, which is going to mutate a value. So I'm sorry about that. What I'm going to do is I'm going to create, I'm going to set a, what do they call it in JavaScript? A property on the JavaScript object. Does this sound like JavaScript type terminology to you? I'm going to create a property called excite me, and I'm going to slap that onto JS window. I should explain some stuff, but just give me a second here. Let's say excite me here. Okay, so this JS / stuff, so Clojure, the original Clojure, its superpower was that it runs on the Java Virtual Machine, or JVM, as the cool kids call it. So one of the things that they really leaned into was interop with the host platform. So ClojureScript is the same. It is not pretending that it's not running on JavaScript. So anytime you see this JS / stuff, this is JavaScript interop. So just pretend that if you're in JavaScript, this part disappears. I mean, you see the part I'm making. I could make it disappear, I suppose. Just pretend that in JavaScript, it's like this. In ClojureScript, it is, you have to say JS. All right. Now that I've done this, I believe I can reload my thingy. And if I click the button, I didn't reach for, yeah, sorry, too late. Thank you. Thank you, Martin. All right, so stuff happened. This is exciting. Alerts are kind of corny, however, in 2024. So let's actually make the page non-boring when I click the button. So how about I set maybe the inner HTML, does anybody see where I'm going, of a thing here, of maybe like that div I was talking about, and like maybe I could set it to some cool text like on a new line perhaps. Oh yeah, this does not know about indenting Clojure. This is emoji for the kids and it's fire. All right, but div, yeah. Which div, Josh, you may be asking. So let's grab ourselves a div. So we have JS document, I think it is. And document has a thing called query selector. You people who actually know JavaScript, if I start typing something that makes no sense, you're allowed to yell at me and or throw something. Soft, please. So let's then, sorry, I'm just trying to make this fit on the screen. The formatting is dreadful. Don't yell at me. So let's grab my div, which had the ID of text, right? And then if I do this, yeah, good stuff happened. All right. Let me format this in a somewhat reasonable fashion. Should be like that. Okay. So what I hope is going to happen is when I go to the web browser and reload and I click this button, all right, so far, so good, he says. Switching tabs, clicking here, clicking there, clicking there. All right. So I showed you some awesome stuff, right? Okay, what in the world was all of this? So let's just quickly walk through what we've just seen. So what we saw here is something that none of you can read in the room, but this is my script tag where I was grabbing the skittle.js from npm. So what I'm saying here is like, please load me some JavaScript from the World Wide Web. And it's like, sure, here you go. Here's some JavaScript. If you're in the front row, you might be able to see this is really the JavaScript that is Skittle. And I mentioned that ClojureScript was transpiled. So Skittle itself is written in ClojureScript, then transpiled to JavaScript, and then interprets ClojureScript in the browser. I think I got that right. So anyway, this is really Skittle. It's been run through the Google Clojure compiler. That's Clojure with an S, which is a JavaScript compiler that does tree shaking and optimizations and blah, 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 and has nothing to do with Clojure with a J other than ClojureScript with a J uses it to transpile stuff. Moving on. If you look at the source code of Skittle itself, somewhere in the source code is this function called eval script tags. And it has some code here, which again, you can't read, but basically this code says, find me script tags in my document that have the type application X Skittle. In the code that we wrote, we had one such script with application type X Skittle with our amazing, exciting excite me function. And jumping back to Skittle now, this is more code in the Skittle code base. And so it says, once I've found these things, these script tags, evaluate those script tags. And what we get is this amazing thing. Okay, nice. Right? Everybody, I heard a well. I don't know. Maybe it's coming from the cameras. Yeah, I did. Oh, yes, thank you. But I didn't need applause there because I was a bad person. So it was pointed out I didn't reach for the bottle, which I'm not going to do because that could trigger applause. So, all right. The reason I didn't reach for the bottle is not because I'm not thirsty. I am. I'm parched. I'm dying up here. I do not deserve your applause, okay? I promised you a REPL and I have not delivered. What I've delivered is me writing some code and refreshing a page and then doing stuff. That is not a REPL, my friends. This is a REPL, he says dramatically, and then switches back to Emacs. All right, what is he gonna do now? Okay, so let's be good programmers and move one tiny little step at a time. The first step is this whole idea of writing code inline in HTML and not getting any help from my editor, like how to format code or whatever. This makes me sad. My heart is just full of sadness right now. And so I would like to not be sad, and I would like to put this in a separate file, okay? I know this is revolutionary, groundbreaking stuff. I'm going to make an exciting.cljs file here. CLJS is just the conventional extension, thank you, for ClojureScript files. And I'm going to start it by with a namespace declaration, whatever. I'm going to paste some code in here. Then I'm going to like format stuff like it's really Clojure. All right. So I have an exciting CLJS file here. If I go back to my index.html, what I can do is, just like I did up here, I can also say source here equals exciting dot, and check this out. Emacs knows there's a file on my file system called exciting CLJS. Yeah. Give it up for Emacs. All you Vim users in the crowd are so angry right now. I love it. I feed on your rage. All right. Cool. So exciting CLJS is now in a file. And I am going to pop back over here and I'm going to reload this page. And I am going to be bored and also screamed at by my web browser. So what in the world is going on here? Anybody who has ever done any JavaScript development in your life, I am sure has run into a CORS error at some point, right? CORS is the most secure thing in the world because it doesn't let you do anything, such as run code that you really want to run. This is probably a good thing, right? So it's like, yeah, you told me to like load some file off your file system and like execute it, and I don't really think that's a good idea, okay? So yeah, maybe. What are we gonna do? All right, panicking is one option, especially in a live demo, right? I'm sweating here, but I'm not really sweating because I actually planned this whole thing. So, whoa, interesting. This should not have happened. Okay. This presentation software is written in ClojureScript. Not by me, but I was involved with the company that did that, which is probably why that bug exists. You can blame me for all bugs in the pitch software. Babashka has got us covered here. So before we demonstrate this, we had better talk about Babashka. So what is Babashka? This little friendly person in the red hoodie and the dope Lambda sunglasses, also featured here on my shirt. You can purchase one for the low price of, I don't know, 20 euros. See me after for the link. Babashka is a fast native Clojure scripting runtime. Let's unpack that. All right, so it is a Clojure interpreter for cross-platform scripting. That word interpreter there is kind of an important word. Inside Babashka lurks the small Clojure interpreter, or SCI. So just like Skittle is a thin, delicious wrapper of JavaScript around SCI, which is doing all the real work, Babashka is a not so thin layer of Clojure around SCI fed through GraalVM to produce a native binary which runs on your Macintosh computer running off Apple Power here, or your Linux computer. It really is a Linux computer. It's an inside joke. You had to be here. So it is a single binary native code, again, that starts instantly. And there's a very, very cool thing here, which is it can be statically linked, which is even cooler if you use NixOS, which really hates non-statically linked things. Or if you want to actually write a AWS Lambda function using Babashka, and I have a talk for that, so see me after if you're interested. Babashka comes with batteries included. Batteries such as the ability to transform data from JSON to YAML to CSV to XML or Eden. If you're a Clojure person, that stands for, I think, extensible data notation, but it's just like the way you write Clojure data, whatever. There's an HTTP client and server built into Babashka. There is stuff for HTML. So Hiccup is a way to represent HTML in Clojure data, and Selmer is a templating framework. There's also like stuff for us Clojurists, like rewriting Clojure code and doing like static analysis and all this cool stuff. And it also supports, there are a lot more batteries. I just mentioned these. It also supports loading libraries from the Clojure ecosystem. So not every single Clojure library is compatible with Babashka because some of them depend on Java classes that are not built into Babashka. So with GraalVM, you cannot dynamically create classes. That's a thing that you cannot do. So Babashka has kind of the best Java classes built into it. So a lot of stuff works with Babashka, but some of it doesn't. Don't applaud. I'm just thirsty. Oh, come on. You probably would have forgotten if I hadn't told you not to, right? All right. So Babashka makes Clojure a viable replacement for writing bash scripts, which is awesome because if you're anything like me, you have a problem and you're like, oh, just a little bash one-liner, blah, 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 awesome. And then like, oh, it doesn't quite do everything I needed. So let me like write this into a bash script instead. Okay, 5 lines of bash, awesome. Everything is amazing. Oh, but wouldn't it be nice if my bash script also did this? And several hundred lines of bash later, you find yourself pulling your hair out, trying to remember if bash supports arrays and how those work. And like, is there such a thing as a dictionary in bash? I don't know, maybe. And then you like get angry and port everything to Python. And then if you're me, you get angry because Python is like, you can do functional programming in it, sort of, but Python is like fighting you the whole step of the way. And I just want to write Clojure, and thanks to Babashka, I can. Wonderful. That little icon means it's time for me to go back to Emacs. So I've talked about Babashka, and I've talked about my woes of not being able to serve up a script that has scriptable code. Let's instead write a web server. All right. So I have this time pre-baked this bb.eden file. So just like Clojure itself, so folks that are familiar with the CLJ command line Clojure tool thingy, you can put a file called deps.edn or deps.eden as we pronounce it in a directory, and Clojure will look for that file when you type CLJ, and you can configure it. So Babashka does the same, except they've called the file bb.eden. And one of the cool things that you have built into Babashka is a task runner. So Babashka is also a replacement for make. You don't need make because you have Babashka tasks. So what a task is basically like a subcommand. So just like I would say like get branch, whatever, I can say bb dev, whatever. And in fact, bb dev is the thing that I want to be doing here. So what this is it is a task that runs another task and tells it to run in parallel, please. And then dereferences a promise. Okay, so promise in Clojure with no arguments creates a promise that never delivers, okay? Kind of like UPS, right? You know, here in Sweden, at least, UPS is like, yeah, we'll deliver your package, but oh, you weren't home, and now you have to drive to Arlanda to pick up your package. That's the international airport in Stockholm. When you deref a promise in Clojure, you say, give me the value you promised to deliver. This promise will never deliver, so this deref will block forever. This is just the idiom in Babashka for like, please don't exit. So anyway, the dev task, which we're running in parallel, it depends on 2 other tasks. One of them is called HTTP server, and that is up here. And that is going to, let's move over here. It's going to start an HTTP server on port 1341, and it's going to serve up the files in directory public. And then the other thing that is running in parallel is the browser in REPL. So this is super exciting. In REPL is, it stands for Network REPL. So in Clojure, what this is a bit of Clojure code sitting in your running process, like the program you wrote, a little bit of code hanging out, listening on a network, reading Clojure expressions, also called forms, also called S expressions or sexpers or whatever. Anyway, Clojure code, evaluating the code you send it, printing the result of the evaluation back onto the network, and then looping back to reading again. So this is REPL. This is what a REPL is. Read, eval, print, loop. You heard it here first, folks. Cool. So anyway, I did all of this just so I can do an exciting thing, which is open a terminal and maybe like, oh, fight my window manager and like maybe like go there and like do this. Okay, cool. So I have a terminal and I will make it big. Let's cd into the directory where talks and then that and then live, right? My live demo. Okay, let's do an ls. Yes, bb.eden is in this directory. I'm scared, but I'm going to type bbdev and then I'm going to look away. Everything seems to be fine, right? According to it, it has started serving static assets on some port, and it has also started an REPL server and a WebSocket server. I'm going to like open this link or whatever. Okay, that was super cool, right? Oops, bad stuff. I'm back to my boring page. I should make it bigger. And this is being served up. You can't read this, but this is being served up on localhost. I find this incredibly exciting. Another thing that excites me is I'm going to click this button and it's actually going to work, right? Reach for bottle. But I still haven't given you a REPL, have I? Now I've given you a web server. Babashka was amazing in that it provided a web server unto us with very little code. Because the batteries are included, so you just type bb, whatever it was, start web server, blah, blah. I don't even want to look at the code. It's too boring. So let me give you a REPL then. So let's go back to our HTML, which is not this. So if we want a REPL, what we can do is grab ourselves instead of why do you okay, so just like we got Skittle from npm, we can also get Skittle in REPL from npm. So this is going to fetch I think they're called plugins in Skittle land, but just some more JavaScript. And this JavaScript, if we're really nice to it, will give us a REPL in our browser. But to be nice to it, we actually need to tell it where to find the WebSocket that we started. If you remember over here, we have a WebSocket server start. Oh, I stepped out of the frame. Sorry for you at home. A WebSocket server started on port 1340. So let's just tell Skittle where to find that. So I'm looking at my notes here because I never spell this right. In REPL, WebSocket port, yes, equals 1340. That's what I said, right? And then that's the, oh yeah, we better close the script tag. Nice, okay. So now with this done, I believe, if I go back to my web browser, I reload the page, I'm bored again. I can be excited, so that still works. And let's go back to Emacs now. Let's jump into our exciting ClojureScript code. And this is the moment of truth because I have given you a REPL, but I haven't proven that it exists yet, right? So now I'm about to prove it. So I'm going to say Control-C, L, capital C, which of course is short for Cider Connect CLJS. I'm going to tell it localhost. I'm going to tell it a port. And oh my goodness, what port was it? It was port 1339, 1339. And here for people sitting in the very, very, very front row, luckily you can't even see it because it's off the side of that screen. Oh, yeah. So it's asking me to select my ClojureScript REPL type, and it's giving me like 10 different options. So that's awesome. So I'm going to, just for you, Bork Dude, at home, I am going to select NBB, and I'm not even going to make a snide remark about how NBB is the worst thing you've ever done in your life. Won't do it. All right. Amazing. See, I'm way more mature than I used to be. All right. What I have here, like this actually, oh my goodness, worked. So what we have here, and this is probably super hard to read in the room because it's dark on dark, but CIDR, which stands for the Clojure Interactive Environment that rocks, the T is silent. That's why I said it really low. The D, IDE, Interactive Development Environment. Come on, Martin, try to keep up. I have a REPL here. And to prove that I have a REPL, I'm going to ask it what it thinks about the number 1. It tells me, sure enough, the number 1 is 1. So that's how I know I'm in a REPL. How do I know I'm attached to a web browser? Oh, why did you say alert? I was going to say println. Okay. Oh my goodness, what just happened? I'm getting like completion here. It's off the bottom of the screen, but I'm getting it nonetheless. I mean, this is exciting stuff here. So what is going on here? If we look over here, now this is the terminal where I ran bbdev. You're seeing behind the scenes, this is like a REPL session happening here. So CIDR was like, hey, my person in the editor was like, started typing some stuff. What could that stuff maybe potentially mean running ClojureScript process? And the ClojureScript process is like, well, that person could have meant a bunch of stuff here. So that is how I know that I'm in a REPL. And if I go back here and I finish typing alert, and then I need to say something. No, this is a good thing. This is a good thing. It's not a bad thing. If I execute this, what I expect to happen is that my focus will get stolen by my web browser. And in fact, I'm told that this is a good thing. Thank you. Whew, that was amazing. Flip page in notes. I don't clap again. No. Oh, okay. Yeah, you pre-clapped. You people, thank you, but also I hate you all. All right. Cool. So let's now go back to talking about stuff rather than actually doing stuff. Alrighty. So we talked about Babashka, and so how actually is this useful? Okay. So I have definitely connected a REPL to my browser, and I've like written some stuff in the REPL, and stuff has happened in my browser. However, this is not kind of the height of awesomeness, because what I would like to do, I bet if I press next, yeah, that's what I thought. All right. What I would like to do actually is some kind of interactive development of something. So writing code down here in this REPL buffer is well and good, but the real experience of REPLing is when you're up in this thing and you don't even look at your REPL buffer because you don't care what's happening there because everything is happening here. So what do I mean by all of this? Well, I want to just write code here, all right? And then I want to like run it, and I want stuff to have happened in my web browser. So let's see. Actually, has stuff happened in my web browser? And if not, why not? Oh, it has happened. I was sorry, I was just on the wrong tab. Okay. I had expected stuff to happen. So what was going on here? So I pressed a series of keys here. So first I pressed Control-C, Control-K, and let's just see what in the world that is. So I'm going to say help, tell me about the key Control-C, Control-K, and it tells me it is a command called cider load buffer. Okay, cool. So what I basically did when I did Control-C, Control-K is I evaluated the entire buffer in my running process, right? So in the browser, I evaluated this buffer. What I did that caused this nil to show up here, I did Control-C, Control-V, F, C, E, right? And this happened. And that one, so let's say like help, tell me about key, Control-C, Control-V, F, C, E. And it says that is cider pprint eval last sexp to comment, right? Cider is the name of the IDE. Pprint is pretty print. So it's going to pretty print the result of evaluating the last S expression, right? Which is just Clojure code. And then it's going to print it into my buffer, commented. So that's actually like kind of cool, right? I mean, this is some real programming. So if we reload this page, two things happen. First of all, I got an alert, which is quite annoying. But second of all, my page became boring again. If I go back over here and I say, I wonder, actually, I'm going to make this window a little bit wider because that one being narrow is still fine for now. Alrighty. If I then evaluate this S expression, what happened there? Oh, sorry, I evaluated the wrong thing. What I actually meant to do was just call excite me. Okay, so if I call excite me, okay, so from my code, I can make stuff happen in the browser. I think we've established this. However, every time I reload this page or reevaluate my buffer, I get an annoying alert popping up. This is not a thing that I like. So let's see if we can fix that problem by introducing the comment special form. So cool, everything is in a comment now. All right, so what comment does in Clojure is it treats everything inside this form as a comment. So I just evaluated the buffer, I just reloaded the page, no alerts, no nothing, right? So this stuff here in the comment doesn't happen. This is also a comment, the semicolon, this is also a comment, right? So what is special about saying the word comment instead of just writing a, what's it called, semicolon? So in Clojure, we call these things rich comments because the cool thing is I am inside code that is not going to be run, but I can still evaluate it. So inside the comment form. If I just like go here and I'm like evaluate that, well, that accidentally worked. That was supposed to be like not working, but whatever. The reason that worked is because the last S expression before my cursor actually is this one because a comment is not an S expression, etc. So the reason these are called rich comments is apparently like Rich Hickey, when he was doing early demos of Clojure to like Java user groups, always used to program this way. He would like have code and then he would be doing stuff here. So they're called rich comments. So anyway, that was how this is useful because now I don't need to just type into a REPL buffer. Because if I'm typing into a REPL buffer, I might as well just be typing into the JavaScript console, right? It's no different. So I hope that I've proved how this is useful. All right. Let's set ourselves a challenge and clone Zencastr. What I've shown you so far are just like fun little tricks that are amusing, but not all that useful. I'm just checking my time. Oh my goodness gracious. All right, I better speed up here. Do we actually cut off the stream at an hour? Okay, good. I will attempt to speed up and make fewer stupid dad jokes. All right. So Zencastr, I don't know, has anybody heard of Zencastr? A few of you probably? No. Okay, no podcasters in the, yep, got one. Great. Zencastr is a web-based podcasting platform, which spares you from having to make a Skype call and then figure out how to record the audio and then mix the audio and blah, 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 blah. And it's like, here, how about you visit this webpage and we have a conversation and then we get a podcast and it's amazing. And it really is amazing. And so let's just make our own version. All right. I like spending time in Emacs and not in web browsers. All right. So let's go back to our index.html now. And instead of a boring page, let's call this something like, I don't know, ClojureScript, you know, hip name. Let's get rid of this boring stuff and let's like give ourselves a proud title. So we are writing ClojureScript here. And then like we want some like video in our page and we want this video to like autoplay or whatever. And we want it to be muted from the beginning. And then we want to say that it plays in line. And for some reason, Emacs doesn't know about plays in line, but that is the thing. Some of you probably even know what I'm typing here, right? Like I learned this video stuff about a month ago when I was trying to write the blog post that I then turned into this talk. So I may look impressive up here, but I actually am not because I don't know what I'm doing. I'm just typing stuff. However, I do know that if I go over back to my web browser and I refresh this page, I am now going to be ClojureScript instead of boring. And I bet if I inspect my page source, I will see here that I have a video dealie. So this is going to be tough, right? But I have a video, I have a video dealie here somewhere. I was kind of hoping it would highlight it a little bit. I'm going to make this a tiny bit smaller now that we're not doing things that are super important for you to be able to read. So, okay, here we go. Here's my video element. They're highlighted. Okay. So let's go back to the web browser. So this is all the UI we need for right now. So let's pop back into our exciting ClojureScript code and let's just like throw it all away, but still call it exciting. So how are we gonna, let's actually set out a roadmap of sorts. So what we want to do, and I'm just going to, as I talk, I'm going to engage in some bottom-up design, and I'm going to write code the way I wish it worked. So I want to like load my UI, which is usually spelled like this. And when I load my UI, the first thing I would like to do is I would like to list my webcams that are attached to my system. Hey, Magnus. Wait, you hand me my backpack because I was supposed to have attached another webcam before we started this. Okay. Anyway, I'm going to list my one webcam. You can just bring the whole thing because it's like somewhere in a, okay. Professional production values. Anyway, take a break there at home, fetch a cup of tea whilst I root around in here and find a webcam. All right. This is a webcam, I hope. Yes. This is how you know this talk is live, because we would have not faked this one. All right, so I'm going to just put my webcam like here. All right. Actually, let me point. Is there any section of the crowd that is perfectly fine with being on YouTube? So like if I were to aim it that direction, would that be okay with folks? Okay, you'll only briefly be on YouTube, don't worry. So I'm just gonna kind of aim it like that. And then I'm going to plug it into my computer. Okay, so anyway, as I was saying here, I want to list my now 2 webcams that are plugged into my computer. I want to just like take the first one of them, and then I want to, for example, display video or play video. Play video sounds good. Cool. Okay, so this is code that I wish just worked this way. And in fact, this is valid closure. Is that an actual fire alarm, like for reals? Okay, I was gonna say, if we're doing a fire drill, that would be cool. Okay. Okay, so for all of you at home, we are not actually about to die. There is no fire. That was just a buzzer that went off. You may not have even heard it. All right, so let me write a function called list webcams here. And that is going to take 0 arguments, and it is going to return me a list of webcams. How do I even? And then I want, so first here, that's just going to take the first thing out of my list of webcams. That's a built-in, Clojure built-in. I need another function called play video here. That is going to take a single camera and somehow display the video, please. Okay, so this is Clojure code that I wish worked, but it is also valid Clojure code, except why? Oh, right, because I don't know why I was shouting here. That's why. Okay. By the way, these bangs and exclamation marks, this is a real Clojure convention. What this indicates to the reader of the code is I am going to mutate something. So this function has a side effect, and that side effect is not just println. That side effect is doing something to something. Okay, but I have load UI. I am still attached to my browser here. So I'm going to go to the JavaScript console, maybe, if I can find that. Sorry, let me make this bigger for a sec. Right, let's go back to the JavaScript console. By the way, this is Clojure, or sorry, this is Skittle giving me a ClojureScript error. So I also get those in the JavaScript console. That's kind of exciting. But anyway, what is even more exciting? So maybe I should perhaps make this a tiny bit smaller. Okay. Let me have a rich comment here. And I'll put it way down there so it doesn't run off the bottom of the screen. So I can say load UI here. And if I evaluate that, I get nil. So cool, I guess. I mean, nothing really happened here. But that's not too surprising since none of these functions actually do anything. So let's actually list our webcams for real. How does one list webcams in JavaScript? Does anybody actually know how to do this? Just out of curiosity, Svalin, yeah, one. Nice. I see everyone at home is like, of course. Let's ask our good old friend JS Navigator, or it's our new friend. It's the first time we're seeing JS Navigator, about media devices. And let's ask it to maybe like, I'll just make this big, enumerate media devices. So this is a function that exists in JavaScript. And if we evaluate it, it promises to do something for us. So I guess that's awesome or whatever. Let's see what it's actually promising to do for us, though. So what we can do, oh, sorry, I've used this thread first macro without explaining it at all. So normally in Clojure and other Lisps, you write things inside out, right? So normally I would have to say, play video of the first of the list webcams, which without the bang. So this is like the normal way you do things in Lisp, but this is like super annoying. And I see the Erlang programmers are like, of course, that's the way you write it. How else would you write it? So the Elixir programmers are like, I think you need a threading operator. And the Elixir programmers stole that from the Clojure programmers. So we got one. So what thread first does is it says, take the result or the return value of this function and make it the first argument of the next thing in the chain. and then make the return value of that the first thing in the next value of the chain. And actually, I don't need those parentheses there. Maybe it's just for the sake of explanation, it's easier if I have them. So this is an example of a macro, and you may have heard Lisp programmers say in a superior manner, code is data, data is code. Well, Lisp is literally an abstract syntax tree. So you have macros which run at compile time that literally do transformations on the abstract syntax tree. So that's how all of this stuff works. Anyway, I probably should speed up and not explain things so much. So let's just let's ask this what it's actually doing, and let's use JS console.log to do that. So I'm going to just evaluate this, and then I am going to get an error over here. No, I got a promise. Okay, so that was good. That was amazing. Actually, let's look at what the promise is. It says it's pending, so that's cool. It says it's fulfilled, and it says it has a result. Okay, so cool. This is good, actually. It's got a bunch of input device infos and a few media device infos. So these input device infos include these two webcams and also some like microphones, I guess. And then these media device infos, I guess, are speakers or something like that. So anyway, we now know what the evaluate media devices does, and I think we now have the code that we need. Sorry, let me make this bigger. We have the code we need to put in list webcams. So we enumerate our media devices, and there we have a list of webcams. We take the first one, we play the video. I have no idea how to play the video yet. So instead of playing the video, let's just println playing video from camera spelled like that, and then the camera. Cool. And then what we should be able to do now is when I evaluate load UI, over here, I'll just clear the console and maybe move this up a little bit. All right. When I evaluate load UI here, hopefully I'm going to get some camera printed out somehow. So let's do that. What I got instead is a big fat error that says object promise is not iSeekable. Cool. As everybody knows, what that actually means is that I forgot I was dealing with promises. So I can't just call a function on a promise and expect it to get the first thing. I have to call then, right? Because promise has a method called then. So if I say then first, and then I say, no pun intended, sorry, and then I say then play video, now if I do this, I actually get back a promise. And I also see over here in my console playing video from camera something or other. This looks weird because, sorry, I don't know how well you can read this bottom part here, but this is the way ClojureScript prints out JavaScript objects. It is not very useful, okay? So let's, instead of doing it this way, instead of using println, let's just go ahead and lean into interop and use console.log. So then I go back down here and I evaluate load UI. Okay, and then over here, now I have input device info, and I can actually like traverse it using the console. So I am playing video from a camera. However, this appears to be an audio input. So I could try playing video from an audio input, and like if we're lucky, we would see some really weird stuff. but probably JavaScript would know that that's what we're trying to do and tell us, no, you can't do that. So that sucks. So I think what we have done is found a deficiency in our function called list webcams, in that it returns things that are not webcams. So let's see if we can fix that. So we saw here an input device info has a few properties that look kind of interesting. It has a device ID, group ID, which whatever, we don't care about, a kind, which we care a lot about, I think, and a label, which is default. So the first thing let's do is let's actually make our enumerate devices, our play video list webcams. That's what I was doing. Sorry about that. Let's make this a little more print lineable to Clojure. So what we can actually do here is say, okay, after you have given me, okay, console log, yeah, whatever. After you have delivered this promise, you are going to give me a promise containing a bunch of devices. And what I would like to do with those devices is I would like to map over them with a function that takes a device and returns me a closure map. And I always forget to actually provide the second argument to map, which, because in Clojure this actually works, because what it returns to you is a transducer that, when handed to it a list of objects, will transduce them and run the function on it. That is super awesome, but that is not usually what I mean when I accidentally forget that argument. So I'll write it. So we were interested in the kind of the thing. So this is JavaScript interop. Again, this is the kind property of device. We are interested in the label on it. Label device. I think I misspelled label, didn't I? Yes. Control T, there we go. All right, and then we probably also want to know the, what else was there? Device ID, yeah, the crucial part of it all. Device ID of the device, okay. So now that we've done this, we actually can do then println. And what I expect to happen here, let's evaluate this. So again, like the result of this evaluation is just some promises. But over here in the browser, now I get a Clojure data structure, which is actually kind of useful. So what I try to do whenever I'm doing host interop is I try to convert the data to Clojure as soon as possible, and then convert it back to host native as late as possible if I need to do that. So now that we've mapped over these Java, I forgot. I forgot. All right, so we have a bunch of Clojure code. Cool. So now we are back over here. So let's take this code now. And what we have is now code that Clojure can understand, but we have in this not just video cameras, but we saw also audio inputs and other stuff. So let's break out filter here. So we can do a then, and actually I'm gonna show you one other cool Clojure thing. No, I'm not gonna, how am I gonna do this? I'm gonna do it like this. So I'm gonna say we have some devices, and we are going to filter those devices. Wait, no. Okay, sorry, I keep changing my mind. Okay, we are going to get some devices, and we're going to filter over them with a function that gets a device, and let's put that there, and keeps it if the kind of this device is video input. All right. So once we've done this, I believe, could not resolve symbol. what did I do wrong here? Device as, because yes, this is an this is an anonymous function, so anonymous that I didn't even want to bother saying naming its argument. So I needed to do this instead of devices. But the nice thing is that I was yelled at immediately. So let's just do cool. So now I'm back, and what I get over here is I now only get two devices, and they are both video inputs. So we won there. All right. So now that means that this code that we have written here is what list webcams really should have looked like, right? Perhaps minus this println. All right. Amazing. Now, there's a lot of cleanup of this code that I intended to show you, but I think as we're a little behind schedule, I need to just leave this code as disgusting. Exercise for the reader to make this code nicer. And then I think we actually have done everything we want to do. Yes, amazing. So let's go back to talking. Okay, let's talk about promises. What is a promise? So functional programming, and I hope this crowd will agree with me that it's all about values. And a promise is, in fact, a value. So in JavaScript, it is a value, but it's some kind of weird value that promises to do stuff when a thing that returns a value has, in fact, returned the value. Clear as mud, right? Clojure also has promises, and they are values that tell you if a thing returns a value has returned it yet. So you can ask, hey, have you delivered on your promise yet, UPS? And they can say yes, and then you can dereference that promise and get the actual package out of it. That is a blocking operation, as we saw earlier. Okay, so chaining promises is a genuinely cool thing. So that's all of this stuff that we were doing with then, blah, blah, blah. It works well with Clojure's thread first macro, like this, like we saw. But I always forget the then, and then I get this weird error message, object promise is not iSeekable. So there is, of course, a solution to this problem, and it is called Promesa. And got to go full screen here. So Promesa has us covered for this. Let's explain what Promesa is before showing this. So it is a promise library and concurrency toolkit for Clojure and ClojureScript. Cool. So let me actually show you what that means. So if we go back here to our index.html, just like we pulled down the in REPL plugin here, we can also pull down a plugin which is for Promesa. So let's say Promesa. By the way, Promesa means promise in Spanish, which I just learned when I tried to Google this library and got a bunch of pages in Spanish. Anyway, so one thing you have to remember when REPL driving a browser is anytime you change the HTML page, you actually do then need to go and reload your browser. There are ways around this in much fancier REPL setups involving a thing called React, which I am not going to talk about tonight, except to say that we are not talking about React. So what I can now do, though, is if I go over into my REPL, I can require in the Promesa library. So require, oh, I don't know why that's not tab completing, but anyway, this should be promesa.core as P. So now I have Promesa. And then if I go down to my amazing list webcams function, I can use Promesa's built-in arrow macro, which is the same as Clojure's thread first, except it knows how to wrap these things in a then basically for me. So now I can just write my Clojure without having to worry that, yes, that I've forgotten the thens. So that worked, and that was really awesome. And I was going to go ahead and use ProMesa here, but again, running short on time, I'm sure you're totally amazed by just this much, so let's move on. So back to this stuff. Amazing. Okay, so we have a page that says ClojureCaster, and behind the scenes, we know it's listing webcams, but what we would really like to do is play some video, right? I guess just play some video, not play it again, since we haven't achieved even that yet. All right, so let's get to doing that. Cool. So how do we play some video? So first of all, we know here that we can get a webcam, right? So let's actually play with this down here. By the way, no, I'll explain that in a minute. Okay. So let's just see what the first of these things is, and we can do println. So this is still returning a promise, right? But over in my web browser, it has printed out a thing. I'll just clear the REPL. So this like printing promise tilde thing is not super useful. So from now on, I'm just going to use a different thing that just like prints ephemerally the result of evaluating this, but as soon as I move my cursor, it goes away. So now I'm no longer writing the results into my buffer. So I just wanted to like mention that. Okay, so here we have a video input. And if we want to play video from that video input, we can pop back over into Navigator, Media Devices. Yep. And it is called Get User Media. All right, Get User Media is a function. Again, in my script, I'm going to go to my browser and I'm going to go through some Mozilla Developer Network documentation like I don't know what I'm doing, and we're going to find out together. But anyway, you know I know what I'm doing. So Get User Media, let's just see. Oops, sorry. Let's do like this. So let's see what Get User Media does. It needs an argument which is called constraints. The constraints are, you're asking me for user media, and what this API actually does, and you've all seen this in your web browser, I'm sure, when you go to some like page that wants to use your video or microphone, you get a pop-up. So Get User Media will pop up a little permission dialog and say this page is asking to use your blah, blah, blah. This constraints, it explains what it is you're asking for. So at the moment, we're going to constrain the user media to video devices, which have a device ID of exactly some string. And it just so happens we have some string over here. So I'm going to copy some string. I'm going to paste it in here. I'm going to reformat this mess so we can actually kind of sort of see it. And here's another got you. This is a Clojure data structure. I'm feeding it to a JavaScript API. So there's a little function called CLJ to JS. And I need to just remember to wrap my Clojure data structures in that, or bad things will happen. Oh, that was a mistake. What did I do wrong? I did something very bad. Okay, undo. Good. Okay. So that's that function, and then let's just do a console.log, JS console.log when we're done here. All right, so cool. Promise means things were good. So I get back a media stream over here. The media stream has some properties, whatever. One of them is ID. That one looks kind of exciting, I guess. So now I know how to start. What you can't see is my little webcam recording light just came on. And actually here, the browser is also telling me that this tab is using my camera or microphone. I previously gave it permission because I had a whole song and dance where it's, here it prompts you and blah, blah, blah. And then I realized that was silly. So anyway, we're now recording video. but we're not displaying it anywhere. So that's kind of boring. But let's then take this stuff that we've done, because this is the very first part of play video. I think we will all agree. In load UI, play video, here it is. Okay, so I want to play video from my camera, and this is how I'm going to actually do it. Oop, did I do bad stuff? Yes, I did bad stuff. There we go. Okay, so this exact, I don't want to hard code my device ID. So now what I can do is instead I can say device ID from my camera. And now let's maybe format this in a little more reasonable fashion, now that it fits on a line. Okay. And I don't think the JS console.log there is really all that necessary. And in fact, this now can be println because camera is a closure data structure. Okay, cool. So now I have play video. And if I actually evaluate load UI, so let's just see what happens here. I am going to clear my console. And then I'm going to evaluate this. Sorry, I think I did bad stuff somewhere, but I'm not exactly sure what it was. Cannot read properties of undefined, reading H. Okay, strange. But I feel like I did something bad somewhere, but I don't know exactly what it was. Because this actually worked, right? Oh, okay, I don't need that. All right, let me try this thing again. Okay. Yeah, I don't know exactly what is going on, but I'm going to ignore it because it turned my webcam on. So whatever. Okay, so cool. Now I'm behind in my notes. All right. So we are apparently playing some video here, or sorry, recording some video here due to the red light, but we also want to play it back. So in order to play it, you remember that we have a video tag on our page, right? So let's grab hold of that. So we have JS document dot query selector, was it? I think, yeah. So we can say, give me the video element. And let's just see. Okay, cool. We have a video element. Let's go ahead and actually just grab it up here, video EL, so that we don't have to say this stuff all the time. What did I do wrong? Thank you. Yes, amazing. Clojure programmers have done that before, apparently, in the house. Okay, so given a media stream, which is the thing that is returned by get user media, I think you saw that at some point in the console, right? We can take that stream and we can stuff it into the source object property of a video tag, and it will magically start playing that video. So let's actually do that. I'm going to put my money where my mouth is. So we're going to say p. Actually, we're going to use p-let here. And we're going to say, this is my stream. I'm going to format this in a really strange way, just so most of it fits. Okay, so p-let is a macro, again, that lets you pretend that this is just normal imperative closure. Imperative? Is that the word I meant to use? Sequential? I don't know, whatever, you know what I mean. Normal, non-promisey closure code that is happening. But in the background, it's doing all sorts of stuff with promises. In any case, now I have a binding called stream, and I can do stuff with it, like, for example, set the, what did I say, source object of the video EL, to my stream. And I really hope this compiles. Yes, it did. evaluates. Sorry, I didn't say compiles. It was a thing I didn't say. Okay, so let's go back over here. I'm going to just reload the page just for whatever reason. By the way, reloading the page, I've done this many times, and my REPL doesn't care. It's unaffected by reloading the page. The running ClojureScript process does care. So anything I've evaluated before a reload is going to go away, but the REPL connection itself is still alive. So I can just reevaluate my buffer, and then I can do like this load UI stuff. And we actually got a picture of me. Here I am. Amazing. And I'm going to immediately reload the page. So now we have come to a fork in the road. Because there are two other important features that every podcast platform should have. One of them is a button that actually stops playing video without me having to reload the page. And another one is a selection box that lets you select between these two video cameras. I think, given that I've already been talking for 90 minutes into a 60-minute talk, I'm going to not do that. But I'm going to ask you to imagine that I have done that in the same REPL-driven style. And instead, I'm going to pretend that this has happened. So this is stop. This is where we would have implemented the stop button. Very exciting. This is where we would have put a little select box and let you choose your video camera. And this is the part where I would have declared victory. Actually, I am declaring victory. We have cloned Zencastr. Our clone is perhaps not the most featureful, but it is a thing that does a thing. And we did it in the REPL. With that, my kind of closing assertion to y'all is that a lot of times, and this is actually a serious point, believe it or not. I'm going to finish on a serious note. I think we as programmers, especially in the browser, have become addicted to complexity. I think every time we're like, JavaScript needs to run in the browser. Okay, we need React, we need Redux, yeah, reframe, whatever. We need some heavyweight thing and blah, 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 and single page app and blah, blah, blah. A lot of times we actually don't need that. We just want a way to write code that runs in the browser. And if we are functional programmers or closurists, we would like to do that in our favorite language. And I think Skittle is actually a wonderful way to just very quickly get up and running with a thing. And I mean, this is production quality code. I mean, not the code, because whatever. But this is a real web page that I can ship. And I don't have to build anything. I just put some JavaScript files on some CDN somewhere. And I have HTML and I serve it up and I have a JavaScript application. So what I'm saying is, like, let's get out of the spa and jack into the REPL, please. And with that, I thank you for your kind attention for half an hour longer than I should have been talking. And reach for the water bottle. Thank you.
Thank you very much.
Yes.
Yes.
Yes, thank you for putting up with that.
Really nice presentation. Do we have any questions in the audience? Anyone? No one dares to ask questions now.
Yeah. I was too authoritative.
Yeah, they saw your Emacs setup and then they... Oh my God.
I'm surprised that the angry Vimmer over there didn't ask me a question like, why do you suck? Or something,
We have a question. Yes.
Is it going to be, why do you suck? Because I can tell you.
Thank you very much for your great presentation.
Thank you.
I'm curious if you have worked a lot with like JavaScript and TypeScript, and how you would say that compares to ClojureScript when it comes to like, I've heard ClojureScript uses a lot of memory, but it's a really nice language, and I'm curious about your experience with that.
Fantastic question. In fact, there were questions within questions. So I'm going to answer the easy question first. You asked whether I had done a lot of JavaScript and TypeScript and stuff. You saw my presentation, right? What do you think the answer is? No. Absolutely not. No. My JavaScript knowledge is basically from the days when like ES6 is like new stuff to me. I'm like, what is all this? So I really only do JavaScript stuff when I have to, which is why I really like this kind of workflow. So I know enough about JavaScript. Like I can write JavaScript. Yes, I've done React and that. I haven't done any TypeScript in Anger. I did like a interview challenge in TypeScript once, and I was like, this seems nice, I guess. So does ClojureScript use a lot of memory? Yes. Does any React app use a lot of memory? So the interesting thing here is like, and there's been some debate on the Clojurians Slack about this very thing. And the answer to that question is always like benchmark it and see. So basically, you would be surprised how little memory Skittle is using because it is not shipping the entire ClojureScript runtime. It's actually shipping an interpreter, so which is like a subset. So what you get is a trade-off of slightly slower performance, but definitely like lower memory use. And actually, if memory use is a thing that concerns you, the Bork dude, who is the person who wrote Babashka, Skittle, Psy, has another project called Squint. Because if you squint, it looks like ClojureScript, but it's actually, it doesn't use persistent data structures. So persistent data structures are what gives immutability. So it doesn't use that. So you're actually mutating just like JavaScript, but it looks and behaves like ClojureScript. So long answer to a short question. You look like a man who has a follow-up.
It's curious because I'd be interested in like making a web app with Clojure and ClojureScript, but my concern is that the tooling is a bit like not super used, and there's not too much resources out there, and I don't know how production ready it is.
And by doing this and saying this is a ClojureScript product that generates 5 million euros ARR, so I guess it's production ready. Sorry, that's a cheeky way to answer a legitimate question.
That's a good answer.
Yeah, no, but seriously, lots of people are using ClojureScript in production for like really serious stuff. So yes, it is production ready. Do the tools have rough edges? Absolutely. Oh, the video did not like my aggressive changing of things, clearly. Sorry about that. But yes, the tooling actually does have rough edges. And that's what I mentioned earlier when I was talking about Shadow CL.js. It is fantastic tooling, but you have to really understand what's happening under the covers with NPM and so on. However, there is a really great community behind Shadow. I mentioned Thomas Heller, who is the person who wrote it. He is super responsive on Clojure and Slack. So if you have questions, the community is great. I would really encourage you to just try it out and see what you think. Maybe even start with Skittle, where it's super low risk. There is no tooling here, right? You're just, the only tooling you have is this bb.eden file, which you can copy from me. By the way, this is on or will be on GitHub, so I'll send out the link, and y'all can see like the beautiful version of this code. But yeah, just try it out with Skittle, see what you think. If you like the workflow, then you can move. If you need to, you can move toward the more industrial grade solutions.
Thank you very much.
Thank you for the question. It was a really good one.
you.
It gave me an excuse to talk even longer.
Any more questions? No, everyone's convinced.
Yeah.
We're running home now.
Amazing.
Installing this.
Yeah. I'm obviously going to hang out for another few minutes.
Do it.
Pop a beer open. So if you have questions that you just didn't want to ask in this setting, just grab me and I will talk whilst drinking beer, which is probably a recipe for disaster, but we'll see how it goes. Yeah, thanks again, folks. I really enjoyed this. You've been lovely. Thanks for that as well.
Thank you very much, Josh, and thank you very much, Kivra, for allowing us to be here tonight. And to everyone on the live stream, goodbye.
Bye-bye, webs.
Bye.